A warm welcome to this session of Electrician Trade. Today, we are going to see how to erect an overhead service line pole for single phase 240 volts distribution system in open space. At the end of this session, you will be able to select the type of pole to be erected, fix the cross arm on the pole, select the place to erect the pole, dig the pit and erect the pole. Electrician toolkit and equipments required. DE double-ended spanner set 6 mm to 32 mm. Combination pliers 200 mm. Heavy duty screwdriver 300 mm. Safety belt. Crowbar 2 meters long, 40 mm diameter. Spade, shovel, plumb bob with thread. Jute rope 15 meters long. Hammer ball pin 500 grams. Bamboo ladder. Draw pulley. Aligning rod. Wooden or RCC or iron or tubular pole 6 meters length. MS angle iron cross arm. C-clamp MS size as required with nuts, bolts and washers. Country wood plank 2 meters long, 30 cm width, 5 cm thick. Cement, sand, blue metal chips, etc. as per the size of pit. Stay insulators 2 numbers. Double screw stay tightener 2 numbers. CI cast iron stay plate 2 numbers. Stay rod 2 numbers. Steel wire 16 meters. 15 into 12 mm size MS bolts with nuts and washers. Base plate for pole 2 numbers. Casuarina pole of suitable height 4 numbers. Wooden box of suitable size 1 number. Before getting into practice, let us have a brief look at overhead power lines and the type of poles and towers. In electric power transmission and distribution, mainly overhead power lines are used to transmit electrical energy across long distances. One or more bare conductors are suspended between towers or poles to transmit electrical energy. The poles and towers provide support to the line conductors passing through them. Also helps to maintain adequate clearance between live conductors and ground level. Generally, poles and towers are made of wood, steel or aluminium and concrete. Wooden poles. Wooden poles are made of seasoned wood. They support lines with a reasonable cross-sectional area and have shorter spans, up to 50 meters. The main drawback of using wooden supports are they have propensity to decay below the ground, have a shorter lifespan, say 20 to 25 years only, cannot be used for voltages higher than 20 kilovolts, have lower mechanical strength, need routine inspections. Steel poles. Steel poles are more durable, have longer lives and enable the usage of longer spans. There are 3 different kinds of steel poles: rail poles, tubular poles and rolled steel joint. It needs to be galvanized or painted in order to prolong its life. RCC poles. RCC poles are reinforced cement concrete poles with greater mechanical strength, longer lifespans and are used for longer spans. They need minimal maintenance and have good insulating properties. Steel towers. Steel towers are used for long distance transmission at high voltages. They have greater mechanical strength, longer life and can withstand more severe climatic conditions. Fixing cross arm on the pole. Cross arms are installed at the top of the pole for holding the insulators on which conductors are fastened. Cross arms are made of either wood or angle iron. They are also known as insulator supports. U-shaped cross arms are specially used for three-phase lines. Now, let us start our exercise. First of all, select the suitable place for standing pole as per the span of line. Select the type of pole to be erected. Dig a pit for the pole to be erected. The depth of the foundation setting is dependent upon the density of the soil, depth of frost penetration and structure of the earth. Dig a pit about 1/6 height of the pole having a diameter of minimum 3 times that of the diameter of the pole bottom. Prepare a mixture of concrete having a ratio 1:2:4 as 1 part cement, 2 parts coarse sand and 4 parts 2 cm blue metal chips and pour the same in the bottom of the pit to a height of 15 cm. Leave the concrete and allow it to settle for a minimum period of 48 hours. Fix the base plate to the bottom of the pit. Place the straight pole on the plumb line of the pit and bring the pole near the pit so that the bottom of the pole is at the edge of the pit. Fix a wooden plank inside the pit vertically so that the base of the pole faces towards one side of the pit. Fix the cross arms on the top of the pole below 30 centimeters from top with the help of C-clamps rigidly. Tie 2 ropes just below the cross arms. Place the casuarina pole at a distance of 1/3 height from the top and bottom. Prepare the concrete mixture in the ratio 1:3:4 as 1 part of cement, 3 parts of sand and 4 parts of 1 cm blue metal chips. Lift the poles step by step with the help of cross arm ropes and casuarina poles and place it on the pit exactly in the vertical position by using plumb bob and aligning rod. Pour the concrete mixture into the pit around the pole. Place the wooden box around the pole and pour the concrete mixture into the box to a height of 0.5 meters above the ground level. Leave the concrete for about 48 hours. Remove the wooden box and plaster the concrete above the ground level to have a smooth finish. Fix the stay rod to the ground away from the pole so that the stay wire gets 45 degrees to 60 degrees angle to the ground level. Cut the stay wire into 2 pieces of the required length and fix each end of the stay wire to a strain insulator. Fix other end of the stay wire to the stay rod and tighten them with the help of a thimble. Fix and tighten the stay tightener nut until there is no sag in the stay wire. We must carry out the process with utmost care and safety precautions. Recap. In this session, we have learnt how to select the type of pole to be erected. Fix the cross arm on the pole. Select the place to erect the pole. Dig the pit and erect the pole. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.